Hi, today we are going to see about 5G requirements. The empathy. The implementation of a network is needed to meet the growing demand for faster speed, lower latency, and increased capacity to support emerging technologies like IoT, AI, and AR, VR. Define designing a network to meet growing demands of current wireless networks is insufficient bandwidth, high latency, capacity constraints, inadequate coverage, and security concerns. Ideate 5G facilities real-time communication between IoT devices and cloud services, enabling mission-critical applications such as autonomous vehicles, remote healthcare monitoring, and industrial automation. The combination of 5G and IoT drives innovation across sectors, spurring the development of new products, services, and business models. The prototype is shown in this figure. The creation of a prototype demonstrating the use of 5G for real-time video streaming. The testing is given in this figure. Developing a roadmap for implementation. Deployment plan for integrating 5G technology into existing wireless networks are shown in these figures. The 5G deployment architecture is given in this figure. In option 1 of 5G implementation is traditional LTE with an evolved packet core. Option 2 involves using non-radio to communicate with the 5G core network without using an LTE anchor. Standalone option necessitates constrained NR coverage over the target region. Emerging LTE infrastructure is combined with the new 5G capabilities in 3GPP deployment option 4, 5, and 7. The dual connection is an efficient method to combine the benefits of 5G and LTE to speed up 5G implementation. The overview of 5G generic network architecture is shown in this figure. In this, flat IP idea in the 5G network allows multiple radio access network to communicate using the same single transmitter. GSM, UMTS, GPRS, Edge, LTE, Advanced CDMA 2000, WiMAX, CDMA 1 are compatible with 5G network architecture. Symbolic names are used to identify devices in the flat IP architecture. Architecture decreases the number of network pieces in the data flow. At the heart of the new 5G standard, allowing for the more significant throughput requirement that 5G demands, uses a cloud-assigned service-based architecture that encompasses all 5G activities and networks interconnections such as authentication, security, session authorization, management, and traffic aggregation from end devices. Stresses NFV as an interesting design idea with visualized software functions that can be deployed utilizing the MEC infrastructure. The figure shows the 5G core network architecture functions. In this, the access and mobility management function. In this non-access stratum, signaling termination, NAS ciphering and integrated perfection, registration, control, connection, administration, mobility administration, access authentication and security connected controls are all supported. Session management function involves session administration, user equipment, IP address allocation and management. DHCP operations, NAS signaling termination for session management, downlink data notification, and traffic steering setup for UPF for appropriate traffic routing are allocated. Authentication service server function operates as authentication server. The functional architecture for context and content-aware 5G platforms depends upon three critical concepts, which is flexibility, reconfigurability, and monitoring. Intelligent programs comprises of modules that enhances network performance by using an information-centric approach and utilizing reconfigurability and monitoring capabilities. Multi-node configuration coordination connects the modular and flexible node operation and intelligent program layers to design and implement the method, control, and management plane to allow multi-mode technology organotic software operation. Thank you.